So let's look at the first question of this chapter, which is there are only 5 questions in total, so we will be solving these questions now. First one is, what is the approximate compression ratio of Earth? So first of all, for this, we need to understand that the Earth is compressed. Many of us, many of you might think that the Earth is a perfect sphere, but it's actually not a perfect sphere. Earth does not have a perfect spherical shape. It is slightly flattened at the poles, okay, or you can say that it is compressed. This picture is a little bit exaggerated, but it is actually compressed at the poles. So what does that mean? It means that the equatorial diameter is more than the polar diameter, right? So if the Earth is compressed, it means that the equatorial diameter is more than the polar diameter. Okay. So why is the Earth actually compressed? It's because of the centrifugal force. If you stand in one place and you tie a ball or a stone at one end of a string and you rotate, you will feel some force pulling you outwards, right? So that force is called as centrifugal force. The same way the Earth also rotates, right? We know that the Earth rotates and it takes 24 hours to complete one rotation. So as the Earth rotates, some mass of the Earth move towards the side, the side. Okay, so this is the reason why the Earth is slightly bulged on the sides. So we can say that the Earth is compressed. So, like I said earlier, the equatorial diameter is more than the polar diameter. And by how much? It is more than the polar diameter by 23 nautical miles. Okay. So the equatorial diameter is more than the polar diameter by 23 nautical miles. So how do we find the compression ratio? The question is find the compression ratio. So how will we find the compression ratio? So there is a formula for that. That is compression ratio equals the major axis minus the minor axis divided by the major axis. So this is how we calculate the compression ratio. So the question is, what is the Earth's compression ratio? So here, what is the major axis? Major axis is actually the equatorial diameter, and the minor axis is the polar diameter. So we should know what is the value of equatorial diameter. It is 6,888 nautical miles. Okay, 6,888 nautical mile is the equatorial diameter. So I'm going to write it down here. 6,888 minus minor axis. What is the minor axis? Is the polar diameter. So what is the polar diameter? Remember I told you the difference between equatorial diameter and polar diameter is 23 nautical miles, right? So the polar diameter will be 6,888 minus 23, which will give you 6,865. 6,865 nautical miles. So the minor axis is 6,865 divided by major axis, which is the equatorial diameter, 6,888. So when you solve this question, we get 3.3 into 10 raised to minus 3. This is what we get. So this is same as, so this is the compression ratio that we get, right? So if you want to calculate the question is actually to find in percentage, right? The question is to find in percent what is the approximate compression of Earth, right? So how do we calculate the percentage? If you want to convert this value into percentage, what we do is simply multiply by 100. When you multiply this value by 100, we will get 0.3 percentage. So this is the compression ratio of Earth, 0.3 percentage. So the first one's answer is Charlie. The second one, a graticule is the name given to. Okay, so the meaning of graticule is it is a series of latitudes and longitudes. Okay, so you can also call it as network of latitudes and longitudes. And these are lines, latitude and longitude lines drawn on a chart or a map. So B is the answer. So if you draw a network of latitudes and longitudes on a map or a chart, that is called as graticule. Now, third question. A great circle has its vertex at 70 north and 130 east. So the latitude is 70 degrees north. Latitude is 70 degrees north and the longitude is 130 east. A great circle. What is the position of its south vertex? So what is a great circle? We all know that the great circle is the largest circle whose center and radius is same as that of the Earth, right? So here we can see in this particular picture, we can see the red shaded, we can see two circles, the red shaded circle and the orange shaded circle. So the red shaded circle is the great circle. And as you can see, the center and radius of the great circle will be same as that of the Earth, right? And the orange shaded circle here is the equator. So how many vertex does the great circle have? The red shaded great circle. We can see that it has got two vertex. By the way, what is vertex? The northern vertex of a great circle is simply the most northerly point on the great circle, right? The most northerly point on the great circle is the northern vertex. So this point over here is the northern vertex. And there is one more vertex, which is the southern vertex, which is at the southernmost point of the great circle. Okay, so how many vertex are there? There are two vertex. One is the northern and the other is the southern vertex. So what is the question? Okay, so the northern vertex is mentioned and we have to find out the southern vertex. So how will we calculate that? So here in this particular example, we can see that the northern vertex value is 63 degrees north and 10 degrees east, right? So the southern vertex will be the exact opposite, the point which is exact opposite of on the great circle. Like it will be on the other hemisphere. If northern vertex is on the east of prime meridian, southern vertex will be on the west of prime meridian. If northern vertex is on the west side, the southern vertex will be on the east. So how will we calculate? In this particular example, the northern vertex is at 63 degree north. So the southern vertex will be at 63 degree south. Okay. If one is on the north, the other vertex will be south in the southern hemisphere. Okay. So, for example, if northern vertex is at 45 degrees north. Okay, the northern vertex is at 45 degrees north. The southern vertex will be at 45 degrees south. Okay, if one is in the northern hemisphere, the other will be in the southern hemisphere. So here the northern vertex is 63 degree north, southern vertex is 63 degrees south. And so that was the latitude. Now we have to look at the longitude. Northern vertex here is 10 degree east. Now how will we calculate the southern vertex? It is the antipodal. So we can calculate, the vertices are antipodal, right? So we can calculate that by adding or subtracting 180 degree. By adding or subtracting 180 degree, we can calculate the value. Okay, so here in this particular example, by adding or subtracting 180 degree and 10 degree, we can get the value of southern vertex longitude, which is 170 degree west. Anyways, let us look at the question that we were solving. Here, the great circle, northern vertex is 70 north and 130 east. So here we can see, this is the top view. Okay, this is when you look from the top, we can see the North Pole in the center. So the northern vertex is at 130 degree east. 130 degree east will be somewhere over here. 130 degree east. Now the southern vertex will be exact opposite of that, right? So how will we calculate? Like I told you earlier, you add or subtract 180 degree. So that's how we calculate. So how do we calculate this? There are two ways. So one is by, let's say I'm adding 130 degree, this 130 degree value plus 180 degree. Okay, how much do we get? 130 plus 180, we will get 310 degree. And now we will subtract 310 from 360. So 360 minus 310 degree, we will get 050 degrees. 050 degrees east or west? This side is east and this side is west. So opposite of 130 degree east will be 050 degrees west. Okay, opposite of 130 degrees will be 050 degrees west. So this is one way of solving it. Okay. The other way is, this was 130 degree east, right? So 130 degree east from, and we know this is 90 degree east. From 90 degree east, when you go anti-clockwise, we reach 130 degree east. And what is the difference between 130 east and 90 east? It is 040 degrees, right? Similarly, from 90 degree west, you have to go again anti-clockwise by 040 degrees. That is, you subtract 90 minus 040 degrees, you will reach 050 degrees west. So this is how we calculate the antipodal. And why do we subtract here? Because here we have 90 degree, here we have 0 degrees, which is prime meridian. So as you go anti-clockwise, you have to subtract. And if you're going clockwise, you, you will add. So the second one's answer is the southern vertex is 70 degrees south and 050 degrees west. Okay, now the fourth question. Fourth question, in question 3, at what longitude and in what direction would the great circle cross the equator? At what longitude and in what direction will the great circle cross the equator? So let's look at the previous example itself. So the question was, at what longitude would the great circle cross the equator? So excuse me. So here we know which is the equator. The orange shaded portion is the equator and the red shaded circle is the great circle. So as we can see, the great circle is crossing the equator, right? The great circle is crossing the equator. At how many points? At 2 points. That is one over here and one over here. Okay. So the question is, at what point would the great circle cross the equator? How do we calculate that? So in this particular example, we have the northern vertex and we have the southern vertex. Using these two values, we need to calculate the crossing point, the point at which the great circle crossed the equator. So this can be calculated by, so before this, we need to know one important line, that is this one. A great circle will cross the equator at 2 points, like we just saw, whose longitude is 90-degree change of longitude from either vertices. Okay, so a great circle will cross equator at 2 points whose longitude is 90-degree from the either vertices. 90-degree from the either vertices. So that means from 10-degree east or from 170-degree west, the 2 points will be 90 degrees away. So how do we calculate that? Just by simply adding or subtracting 90 degrees. For example here, 10-degree east. If you subtract 90 degree, that is, if you subtract 10-degree east minus 90, we will get 80-degree west, right? So 10-degree east, 0 degrees east-west, 10-degree west, 20-degree west, 30-degree west, 40-degree west, 50, 60, 70, and 80. So you will reach 80-degree west, which is the crossing point. Now, if you add 90-degree to the 10-degree east, here we subtracted. Now, if you add, you will get the other crossing point. So 10-degree east plus 90, you will get 100-degree east, which is the other crossing point. So this is how we calculate the point at which the great circle will cross the equator. And same way, we can, or there is one more way of calculating, that is by adding or subtracting 90 degrees from this longitude. Always remember, you add and subtract from using longitude, not latitude, because longitudes are those vertical lines from North Pole to South Pole. So by adding or subtracting 90 degrees from 170-degree west, you will get the two crossing points. So to do this question, this particular line is very important. the one which I've highlighted in green, that is the track angle at which the great circle would cross the equator, is based on latitude of each vertex. So the track angle is the question that we just read. We have to calculate the track angle. And this track angle is based on latitude of each vertex. So in the previous example which we saw, we have the two vertex, which is the northern vertex, 63 degree north, and the southern vertex, 63 degrees south. Okay, and we know that it is crossing, the great circle is crossing the equator at 2 points. So we are asked to find out the track angle. So remember, to measure track angle, we always calculate it from the meridian. So I have drawn a blue line here, blue vertical line here, which represents the meridian. Okay, the angle that we need to find is this angle. That is the track angle. The track angle is always measured from the meridian clockwise. Okay, always clockwise. So how do we calculate this angle? We know that the angle between meridian and the equator is 90 degree, right? And we also know that this angle is 63 degrees. How do we know that is 63 degrees? Because it is the latitude of northern vertex or the southern vertex. Okay, the latitude of northern vertex or southern vertex, which is 63 degrees. So to calculate the track angle, we just simply have to subtract 63 from 90. So we will get 0 to 7 degrees. So this is when you are going eastwards, when you're going eastwards from, just a moment. Yeah, this is when you're going eastwards, like this. Okay, this is when you're going eastwards. Now, when you're going westwards, it's different. So when you're going westwards, you have to calculate this whole angle, as in when you're going in this direction. Okay, when you're going westwards, you have to calculate this whole angle. Okay, starting from the meridian, going clockwise all the way till here. So this whole angle, how will we calculate that? So we know that this is 90. We know this is 90. Just a second, I'll just change the color. So we know the angle between meridian and the equator is 90, right? And we also know this angle, which is 63 degrees, right? So we know this whole angle also, which is 180. So we can easily calculate 180 minus 63 will give you, so how do we calculate this whole angle? If this is 63, we can find out this angle, right? Which is 180 minus 63. When we do 180 minus 63, we get 117 degrees. I'll just clear this. So this angle is 117 degrees. So 90 plus 117 will give us the whole angle, that is this much. So that is the track angle if you're flying westwards along the great circle. Now let us look on the other side, on the other crossing point. So on the other crossing point, what is the track angle is the question. So how will we calculate that? Here again, I have drawn a blue line which represents the meridian. Okay. And now first, let's imagine we are flying on a easterly track. Okay, wait, let's imagine first you're flying easterly track. So you're flying like this towards the east. Okay, you're flying towards the east. So because the track angle when you're flying easterly and westerly, it will be different. So first we will look at easterly track example. So same like I told you, again, in order to measure track angle, you have to consider clockwise from the meridian, right? The angle clockwise from the meridian. So when you're looking from the other side, when you're looking at this meridian or the great circle from the other side, clockwise direction will be opposite, right? So it will be this way, right? So starting from the meridian till the great circle. So this is the track angle if you're flying easterly. So how will we calculate this? We know that this angle is 90, and we also know that this angle is 63, same as this. So 90 plus 63. 90 plus 63 will give us 153 degrees. So 153 degrees is your track angle on the other crossing point, okay, when you're flying easterly direction. Now, what if you're flying westerly? Let me just erase all of these. So this time you're going westerly. So you're going like this. You're going towards the west, like this, in this direction. So how will you find the track angle? Same way, you will measure from the meridian, clockwise direction. And since it's on the other side, the clockwise will be like this, right? You go clockwise and all the way till here. So this will be your track angle when you're going on a westerly track, that is towards the west. So how will we calculate this angle? So we will calculate that by, we know that this value is 90 degree, right? We know that this whole angle is 180. And we also know that this angle is 63, right? So 63 plus 180 plus 90 will give us 333 degrees. So this is your track angle when you're flying westerly. Okay, whereas if you're flying easterly, it would be 153 degrees, like I said earlier. So this is how we calculate the track angle. Let's, the last question is, the compression value of Earth is given, which is 1 by 297. The semi-major axis of Earth measured at equator is also given, which is 6,378.4 kilometer. What is the semi-minor axis? Semi-minor axis is actually the radius of Earth. Okay, so find the semi-minor axis of Earth measured at axis of the poles. So like I told you earlier in the first question that we did today, the compression value is equal to major axis minus minor axis divided by major axis. Similarly, the compression value here we can calculate by using the formula semi-minor major axis minus semi-minor axis divided by semi-major axis. So compression value is already given, which is 1 by 297. Semi-major axis also given, which is 6378.4 minus semi-minor axis. I'm going to write it as x divided by the semi-major axis, which is 6378.4. So when you calculate, we will get the value of x. We can calculate this by cross multiplying. So when we calculate, we will get the value of x as 6356.9 kilometers. So B will be the correct answer for this particular question. So the formula is very important. That is major axis minus minor axis divided by major axis. This is the formula to calculate the compression value. So that's the end of questions from this chapter.